So this is our second and final section on functions this quarter. And so you might remember in the last section, we evaluated functions. So for instance, this f of 4, we would look at the graph that says f, and then we'd say when the x is 4, what's the output? So f of 4 would be, oops, grab a pen, there we go. F of 4 would be 2, because when I put in 4 into this function, I get out 2. But this section, instead of stopping at evaluating, we're also going to do operations. So that's what that plus is there. So you'll see we have addition, subtraction, multiplication, division, amongst some other things coming up. So here we're saying f of 4, cool, we evaluate that and figure out that it's 2, and then we're going to add to that whatever g of 3 is. So then we have to come over to this table, it's labeled g of x. So when I put 3 in, the output is 1. And so 2 plus 1 would equal 3. So very similar to what we're doing last section, but just extended a bit in this case, with a little bit of algebra at the end. So here g of 5, so when x is 5, the output would be 4 minus f of 0. So when the input is 0, the output is 1. And 4 minus 1 would equal 3. F of 4, so that was 2. This one is multiplied, so times g of 5. So we put in 5, we get out 4. And we get 8. And then lastly, g of 3 would be 1. F of 0 we just got, and that was 1 as well, and 1 over 1 is 1. So that's how that would look from a graph and from a table. And then next we have the more algebraic version. So there are two notations, and I think the problems I got to choose from mostly use this one. But f plus g of 0, that does not mean multiply by 0. This means the exact same thing as f of 0 plus g of 0. And that seems to be on exams where people get really confused by that notation, and realize for the rest of math you'll see it written both ways. There's just two correct ways to write it, and those mean the exact same thing. I would encourage you to think this one because it's a little easier to me, but the exact same thing. So this means to put 0 in for the x's of f, and then to put 0 in for the x's of g, and then to add those two results together. So if we do that, for f we would have 0 squared plus 9 times 0 plus 14. And I'm going to throw parentheses around that. It's not necessary when it's addition, but if this was subtraction, those parentheses would totally matter because we'd be needing to subtract everything in this last set of parentheses, so still a good habit. Evaluating that at 0, we'd have 0 plus 7. So this is just a bunch of stuff dropping out, leaving that 14. It's nice when it's 0. 0 plus 7 would be 7. And our final result on that one's 21. F divided by g evaluated at 1. So I could, with this last one, this is probably the better example, there was another way to do it. I could have added these two functions together first and got x squared plus, that would be 10x plus 21, and then plugged in the 0, and all those x's would have dropped out, and the 21 on the end, I would have gotten the exact same answer. And that's actually kind of what these are saying, is you can't add them together first and then evaluate, or you can just straight up go to the evaluation. I usually just go directly to the evaluation, but both of those things are an option. This one means the same thing as f of 1 over g of 1. There's no reason to write it that way, but it's good to recognize, in case this one is clearer to you, which it is to me, that these mean the exact same thing. So we'll evaluate f at 1. And then divide that by g evaluated at 1. So let's see, that's 1 plus 9 would be 10, plus 14 would be 24, and that's over 1 plus 7 would make 8. Always remember to reduce your fractions, so 24 divided by 8 would make 3. So these next ones, they're going to use that other notation, and the reason is they're evaluating it at different values, and so we couldn't write it like we did up here. So that's what I was saying, is you'll see both of these as you go through the homework. I don't know why they picked big old numbers, but they did. So I'll use my notes here a little bit. F of 15 minus g of 7, so there's a minus, and that is where we do have to be careful with some parentheses. So we'll go 8 times 15 minus 5, and then minus g evaluated at 12. So this is where we want to do all that math in there, put that together, make a single number, and then subtract that number. If you don't, you would have to distribute that minus sign to all three terms. So I encourage you just to make a number and then subtract at the end is the easiest way. So 8 and then 12 squared plus 6 times 12 plus 9. And so from there, bust out a calculator and you'll get this number will be 115 minus, and then if you throw that in the calculator, I got that to be 1233. And I would be careful about trying to put the whole thing in the calculator just because you have to be so careful with parentheses. So I suggest again, make this a number, and then do your subtraction. So 115 minus the 1233, and we should get negative 1118. This next one, same idea, but it's a multiply. So that would look like, and then 4s and 7s, so f of evaluated at 4 would be 8 times 4 minus 5. And then that's going to be times g evaluated at 7. So we'll just plug 7s in for those x's. And so again, ultimately we want to multiply these two things together. So I just want to throw this, 32 minus 5, and get that would be 32 minus 5 would be 27 right there. I'll just leave it in the parentheses. And then 49 times 8 plus 42 plus 9, again throw all that in the calculator, and you'll get 443. And now we have two solid numbers. We'll just multiply those together and get a giant number, which is 11,961. So then this last example, it's still operations, except now you notice there's no numbers, so we're just going to do these algebraically rather than evaluating. So these are the three props. So this first one, f plus g of x, again, that doesn't mean multiply by x. What that means is f of x plus g of x. So those mean the exact same thing. So f of x is x squared minus x minus 2, and we're going to add to that g of x, x minus 2. Since I'm adding, I'm not writing the parentheses. When we go to subtract, then that's where, again, we have to be careful with parentheses. So the subtraction makes it all the way through the second term. From here, it's just combining like terms like we were doing earlier in the quarter. So x squared minus x plus x, those canceled. Those are gone. Minus 2, careful, that's minus 2 minus another 2, and that would be minus 4. And that's it. Once you have all your terms as simplified as you can, you're done with these ones. So the second one is f of x minus g of x. Same basic deal. It's really just, we got to be careful with the parentheses on that. So x squared minus x minus 2 minus, open that parenthesis, and x minus 2. So you might remember all the way back to like the first chapter when there's, when you're subtracting with the parentheses, it's like a negative 1 that we have to distribute that sign. So let me go ahead and show that written out. So that would mean that would be a minus x and a plus 2 when I distribute that negative through. And now just like over here, we'll collect our like terms. So x squared minus x minus another x. Again, careful on those signs. We're going minus 1 would make minus 2x. And then minus 2 plus 2, those have opposite signs, so those would cancel. And what's left there would be my final. And then here we have f times g of x. I'm going to actually write that as g times f just because I like multiplying two things by three things better. So let me set it up that way. You could do it the other direction as well. You get the exact same thing. I just feel like it flows better this way for me. And so I'm going g of x times f of x, but like we saw previous sections, 2 times 3, right? It's the exact same thing as 3 times 2, so I can change the order for multiplication. And then just a reminder how to FOIL 2 things times 3 things. So remember, we're going to multiply that x through all 3 terms, so that would give us x cubed minus x squared, adding exponents there, 1 plus 2, 1 plus 1, x times negative 2 for minus 2x, and then we do the same thing with the second one. We multiply that to all 3 pieces. So if I'm doing 2 things by 3 things, I should have 6 terms to simplify, assuming I don't jump anything here. So this will be minus 2x squared, minus and minus would be plus 2x, and minus makes a plus 4 right there. So then just to finish up, we want to simplify. So we've got x cubed, I have minus x squared minus 2 more x squared, so minus 1 minus another 2, that makes minus 3 x squareds. I have minus 2x plus 2x, those have opposite signs, so those just drop out, and that plus 4 on the end. And that wraps up 6.2.